Ignition confirmed and liftoff achieved. Early assessments warned of the risk of capturing only blurred images unless we intervened with spacecraft adjustments. It's a reminder of the humility instilled by science amidst the infinite expanse of space where NASA's Voyager 1 silently traverses, a testament to human curiosity now over 45 years into its space journey and positioned 224 billion kilometers from Earth. Voyager 1 has started transmitting enigmatic data that has left scientists baffled. In this exploration, we delve into the enigma surrounding the Voyager 1 probe's recent anomalies. Are we on the verge of losing connection, heralding the probe's ultimate demise? Is there a possibility of extraterrestrial interference with Voyager 1? Join us as we journey through space to decipher these unusual signals and uncover the true state of this iconic explorer. To grasp the significance of Voyager 1's predicament, we must first acknowledge its monumental voyage. Launched in the summer of 1977, the Voyager mission was initially expected to last just 5 years. Yet, defying all odds, Voyager 1 and its twin Voyager 2 have shattered these expectations. Initially tasked with exploring Jupiter and Saturn, they succeeded beyond their original mandates. Voyager 2 went on to provide humanity's first close-up views of Uranus and Neptune during the Voyager Grand Tour, marking a groundbreaking achievement in space exploration. In a landmark event of August 2012, Voyager 1 entered interstellar space, achieving this milestone 35 years into its mission. Though this feat was only confirmed by NASA in 2013, upon reaching interstellar space, Voyager 1 encountered a new realm filled with constant streams of particles and magnetic fields distinct from any previously observed. Its sibling Voyager 2 ventured into this uncharted territory in 2018, solidifying their status as harbingers of human ingenuity. Now 177 billion kilometers from the Sun, Voyager 1, the farthest human-made object from Earth, continues to expand our understanding of space. These missions have revolutionized our knowledge, revealing the interactions between the solar wind and the interstellar medium and shedding light on the heliosphere's nature. Voyager 1's journey has not only expanded our knowledge but has also captured the human imagination, serving as a monumental legacy of space exploration. As for the potential encounter with extraterrestrial life, scientists speculate that the earliest contact could occur by 2029, hypothesizing that messages sent via Voyager 1 might have reached intelligent life forms as early as 22. This potential first contact could mark a transformative moment in human history, stirring widespread curiosity about the implications of such an encounter. Reflecting on Voyager 1's resilience, it's its durability that stands out. Imagine a device enduring the vast void of space, facing intense radiation, extreme temperatures, and the constant threat of micrometeorites. Despite these challenges, Voyager 1 has continued its mission for an astounding 46 years and counting, a testament to human engineering and the spirit of exploration. A big reason behind the staying power is that it was built well, a salute to the brilliant engineers and officials who crafted the spacecraft. They ensured it could handle a pounding from cosmic radiation, extreme hot and cold swings, and those pesky little space rocks. The probe has also survived for so long due to its power source, nuclear batteries, also known as radioisotope thermoelectric generators, RTGs. These aren't your typical batteries. They convert heat from the natural decay of plutonium into electricity. These RTGs have been Voyager 1's power system's reliable heart, keeping it strong for more than 4 decades. Over time, their power output has dipped due to radioactive decay, but they still provide enough juice to keep all the scientific instruments on board humming. Voyager 1 isn't just any spacecraft. It's also a brainy explorer. It's packed with instruments like a scientific Swiss Army knife. Voyager 1 is equipped with the Cosmic Ray Subsystem, CRS, High-Gain Antenna, Imaging Science Subsystem, ISS, Infrared Interferometer Spectrometer, IRIS, Low Energy Charged Particles, LECP, Magnetometer, MAG, Optical Calibration Target, OCCT, Photopolarimeter Subsystem, PPS, Planetary Radio Astronomy, PRA, Plasma Science, PLS, Plasma Wave Subsystem, PWS, and Radioisotope Thermoelectric Generators, RTGs, and an Ultraviolet Spectrometer, UVS. These instruments aren't just fancy decorations. they've done some serious work. Voyager 1 has used them to unravel mysteries about giant planets and their moons. Close-up snaps from the spacecraft have given us the lowdown on Jupiter's swirling cloud patterns, wild winds, and storms. It even spotted a volcano on Jupiter's moon Io. Over at Saturn, the rings were more than just pretty jewelry. They had peculiar twists, turns, and spokes. But it's not just about pretty pictures. These instruments have also been cosmic detectives. They've dabbled in cosmic rays, studied charged particles, poked at magnetic fields, and eavesdropped on plasma waves. Meanwhile, as Voyager 1 hurtled through the cosmic void, it carries a remarkable treasure, a message from Earth destined for the unknown. This unique record, known as the Golden Record, is humanity's attempt to communicate with any extraterrestrial being that it might encounter on this endless journey. The Golden Record is a remarkable artifact, a 12-inch gold-plated copper disc holding a trove of sounds and images carefully chosen to depict Earth's diversity of life and culture. It is a window into our world, a story of our species and planet, an attempt to bridge the gap between civilizations separated by the vast expanse of space. Within the confines of this small, shimmering disc are 116 images and a symphony of sound. Among them are the harmonious melodies of our music, spoken greetings in 55 languages from different corners of our globe, and the raw, unfiltered sounds of nature. Thunderclaps, the songs of birds, and the haunting calls of whales. Each element was handpicked by a committee led by the renowned astrophysicist Carl Sagan, representing a tapestry of our world's cultures and experiences. The Golden Record is entrusted to Voyager 1 and its twin craft Voyager 2. It's fascinating to think that these Voyagers carry a message from Earth that could be discovered by extraterrestrial life in the distant future. If by some incredible chance an advanced extraterrestrial civilization were to come across Voyager 1 and retrieve the Golden Record, it would be a momentous event in the history of interstellar communication. Here are 3 possibilities of what might happen. The extraterrestrial civilization would likely attempt to decipher the contents of the Golden Record. With their advanced technology, they can understand the visual and auditory information encoded on the disk. Secondly, if extraterrestrial beings were capable of interstellar travel or communication, scientists predict that they might subsequently return a signal, expected to reach Earth by 2029. Alternatively, they might choose not to interfere with Voyager 1 and simply study it as a historical artifact. They might want to respect the principle of non-interference in other civilizations' development, a concept explored in many science fiction stories. In any case, if there were ever an encounter with extraterrestrial beings, it would be a massive and potentially world-changing event for humanity. However, Voyager 1, despite its long and faithful service, has recently introduced an element of intrigue into its mission. It has begun transmitting perplexing data from the fringes of interstellar space, sending NASA engineers into a state of bewilderment. This anomaly stems from a crucial onboard system known as the Attitude Articulation and Control System, OACS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position in the unforgiving expanse of space, ensuring that its antenna stays pointed toward Earth for communication and data transmission. Yet, inexplicably, the OACS returns data that contradicts the spacecraft's actual movement and orientation. It's as if Voyager 1 has become disoriented, uncertain of its location in the cosmic void. NASA's assessment of the situation is reassuring yet perplexing. According to NASA, despite the erroneous data from the OACS, Voyager 1 continues to function normally. It dutifully receives commands from mission control on Earth and diligently collects valuable scientific data from its distant vantage point. The spacecraft seems undisturbed by the anomaly, and no onboard fault protection systems have been triggered, those safeguards that would put the craft into a protective safe mode. Intriguingly, Voyager 1's communication signal remains strong, a steadfast beacon in the void. The high-gain antenna is unwavering, pointing in the right direction toward its home planet. But the mystery deepens, for the telemetry data returned by the OACS appears to be generated at random or, at times, defies any logical interpretation. Suzanne Dodd, the project manager for both Voyager 1 and Voyager 2, sheds light on this confounding situation. She reminds us that such mysteries are not entirely unexpected in the twilight of the Voyager mission. These spacecraft, now aged beyond their intended lifespan, have journeyed farther and longer than anyone dared to dream. Moreover, they traverse interstellar space, a harsh, high-radiation environment, an uncharted territory where no spacecraft has ventured. While the engineering team is facing a tough challenge, they're optimistic about finding a solution for Voyager 1's problem with the OACS. If they pinpoint the source of the issue, they might be able to fix it with changes to the spacecraft software or by using backup hardware systems. It's worth noting that Voyager 1 has encountered a similar hurdle before. Back in 2017, the primary thrusters started showing signs of wear and tear. The engineers had to switch to thrusters that hadn't been used for 37 years during the spacecraft's planetary missions to keep the mission going. But now there's a new twist in the tale. NASA's clever engineers have identified the problem with Voyager 1. It turns out that the OACS was sending telemetry data to a computer that had failed a long time ago, and this corrupted the data. The project manager suspected this was the culprit and took a calculated risk by repeatedly commanding the OACS to send data to the correct computer. While the engineers are still uncertain about why the OACS veered off course, a malfunctioning command from another onboard computer likely triggered this anomaly. If that's the case, it suggests that an underlying problem on the spacecraft may exist elsewhere. The team remains committed to uncovering the root cause, although they believe it doesn't significantly threaten Voyager's overall health. Nonetheless, they are eager to understand Voyager 1's inner workings better. However, it's important to recognize that Voyager 1's journey through space will eventually end. In fact, time is running out for this intrepid explorer. This leads us to a pressing question. How long can NASA's Voyager continue its incredible journey through the cosmos? This question is a fascinating one with multiple aspects to consider. But before we delve into this, it's essential to understand how Voyager 1 manages to communicate with us from an astounding distance of 24 billion kilometers and the factors determining how far it can go before we lose contact altogether. Voyager 1's ability to stay in touch with us hinges on a well-thought-out radio communication system that is meticulously designed to work efficiently within and beyond our solar system's boundaries. At the heart of the system is a sizable 3.7 m diameter high-gain antenna, HGA. This mighty antenna plays a crucial role in transmitting and receiving radio waves, and does so through the 3 Earth-based stations that make up the Deep Space Network. When Voyager 1 communicates with Earth, it usually does so via Deep Space Network Channel 18, utilizing radio frequencies of either 2.3 GHz or 8.4 GHz. Conversely, when we send signals to Voyager, we do so at a frequency of 2.1 GHz. This sophisticated communication setup allows Voyager 1 to maintain a connection with our home planet even as it journeys into the vast unknown. However, the distance Voyager 1 has traveled means that direct communication with Earth has become increasingly challenging. To overcome this, the spacecraft is equipped with a digital tape recorder, DTR, capable of storing roughly 67 megabytes of data. This recorded data can then be sent back to Earth later when conditions for communication are more favorable. As of 2023, it takes over 22 hours for signals from Voyager 1 to reach Earth, which is a stark contrast to the roughly 15 minutes it takes for the Mars rovers to transmit data back to us. Another essential factor to consider is the weakening of Voyager 1's signal as it traverses the vast cosmic distances. The spacecraft initiates data transmission to Earth using a 20W signal. However, over its long journey through space, this signal progressively weakens. By the time it reaches Earth, it has become exceedingly faint. Nonetheless, the strength of the signal isn't the primary concern when communicating with objects at such colossal distances. The critical factor is having a susceptible receiver capable of detecting these faint signals. To meet this challenge, NASA relies on the Deep Space Network, a network of 3 antenna complexes strategically positioned around the Earth. Each complex boasts a substantial 70M antenna and multiple 34M antennas. These facilities can combine their capabilities to detect signals that are thousands of times weaker than a standard FM radio signal. The Deep Space Network allocates several hours each day to monitor these faint signals from Voyager 1 and has consistently demonstrated its responsiveness over the past 5 decades. Our methods for detecting these signals have seen significant advancements. Consequently, there is no practical limit to how far we can extend our reach in communicating with distant space explorers, provided we possess sensitive and precise receivers to capture these exceedingly weak signals. So how far can Voyager 1 truly journey into the depths of space? The answer lies in the ever-expanding gulf that separates it from our home planet. With every passing day, Voyager 1 is further away, a celestial messenger on an endless odyssey. However, sending and receiving signals become increasingly challenging as Voyager 1 ventures farther from Earth. The data rate slows down, making it progressively more difficult for us to communicate with this intrepid traveler. Despite these challenges, Voyager 1's journey knows no bounds. Theoretically, there is no set limit to how far we can extend our communication. Yet, in practical terms, we face a harsh reality. Our ability to communicate with this remarkable spacecraft has an expiration date, and this date is just a few years away. Voyager 1's finite energy reserves limit its capacity to collect scientific data. One of its key instruments, the Cosmic Ray Subsystem, CRS, is on a mission to collect data on cosmic rays, a mission that will eventually come to an end as the spacecraft's power supply dwindles. Currently, Voyager 1's power is generated by its 3 radioisotope thermoelectric generators, RTGs, which convert the heat generated by the natural decay of plutonium-238 into electricity. However, over time, the decay of plutonium-238 will reduce the RTG's power output, eventually rendering them incapable of meeting the spacecraft's power requirements. The rate of power decay is exponential, meaning that Voyager 1's energy reserves will deplete more rapidly in its final years than in its earlier decades. As a result, the spacecraft will gradually shut down its non-essential systems to conserve power, prioritizing communication and critical scientific instruments. In 2025, Voyager 1 will celebrate its 50th anniversary since launch, a remarkable milestone that few spacecraft have achieved. However, this golden jubilee also marks a bittersweet moment in the spacecraft's journey. With each passing day, Voyager 1 inches closer to the end of its mission, a mission that has reshaped our understanding of the cosmos and inspired generations of scientists and dreamers. As we bid farewell to this intrepid explorer, we celebrate its indomitable spirit, its enduring legacy, and its timeless message to the stars. Voyager may first be a small spacecraft adrift in the vastness of space, but its impact on humanity is immeasurable. It has not only expanded our horizons, but has also sparked our curiosity, imagination, and sense of wonder. In the twilight of its mission, Voyager 1 reminds us of our place in the universe. A pale blue, suspended in a sunbeam, a fragile oasis in the cosmic ocean. And as it sails ever onward into the unknown, Voyager 1 carries with it the hopes, dreams, and aspirations of all humanity, a testament to the boundless spirit of exploration that defines us as a species. As we contemplate the future of Voyager 1 and its eventual journey into the void, let us pause to reflect on the profound legacy of this iconic spacecraft. For in the story of Voyager 1, we find the story of ourselves, a story of courage, curiosity, and the unyielding quest for knowledge. And though Voyager 1 may one day fall silent, its message will endure, a testament to the enduring spirit of exploration that transcends the limits of space and time.